We are going to discuss about the CO2 fixed installation for the cargo hold, or it is also called the smoke extraction system. Okay, so why it is called a smoke extraction system? Because on continuous basis the smoke is sampled from each cargo hold, and it is giving you the indication or early indication of the fire in the cargo hold, and accordingly you can detect the fire and you can extinguish the fire. Okay. Now in this slide we will learn about the description of the your fixed CO2 installation in the cargo hold, or you can say the smoke detection operation, how it is being done. Okay, so in this cargo hold system we have the smoke sampling, and each and every individual cargo hold is connected like that. We have the sampling fan, and it withdraws the smoke from that individual cargo hold if at all fire is there in that particular cargo hold, and that will be detected by the smoke sensor. And you can see also you have the LED light also, and it can be found out that the smoke is coming, and that can be also confirmed through a valve system, and you can easily find out that this is something which is showing a continuous sampling of the system, and each space is continuously sampled, or the sample is drawn by the fan. Complete diagram which I have talked, you can see that this is your extraction fan. This is one of the main component, and you have this diverting three-way valve. Okay, so you can see that some part of it can go to the wheelhouse also, and then finally it is going to the atmosphere or outside the wheelhouse. And this sample is drawn, and you can see that individual sampling pipes. These are the individual sampling pipes of the different cargo holds, which is shown over here, and this is passing through this three-way connecting valve. This is your three-way. So this is in this position now. It is taking the sample and it is passing through this, and then you have the smoke obscuration detector, and this sample is being taken and discharged out. Okay, so this is the diagram, and you can see over here these are the labeled chimney. Means it will detect, it will tell that okay, number 1 cargo hold, number 2 cargo hold, number 3, number 4, number 5, like that. These cargo holds indications are there, and the lightnings are also there, which will see about these propellers are turning on. These are the small nylon propellers which will tell that okay, the sample is continuous. If it is turning, that means continuous sampling is done. Otherwise, if it is stopped, that means no sampling is done on that particular cargo hold. Okay, and these are the nylon propellers which is helpful in that. Okay, and this is the detecting cabinet in the wheelhouse, which will clearly indicate the thing. Okay, and you have the CO2 bottle battery which is there in your CO2 room, and the individual discharges can be done when required, when and even required for the cargo hold. Okay, now you can see the continuous description of the sample which is discharged into the wheelhouse, basically to check the smell of the smoke. Otherwise it vents atmosphere. What type of fire? So the sampling part, you can open it and you can check it into the wheelhouse also, because the end of the pipes in the holes can become blocked. It is possible with the dust or with the cargo and all, so possibilities are there. So indicators are also fitted that will demonstrate the airflow. Okay, and these are the light propellers which will rotate by the airflow. So that means these light propellers will have the complete indication. If it is turning, the sample are passing through that. Any smoke issuing from the pipes in the cabinet is emphasized by the diffused lighting and should be visible. Means if it is a clear lighting, that means there is no smoke, only air is passing through that. And if it is a smoke, then you will have the diffused lighting, or you can say the blurred view, or you can say this photo cell detector will automatically operate an alarm due to this diffused lighting system. Okay, and continuation of this, the three-way over there, this three-way valve is fitted on each pipeline, which I have already explained in the diagram below the smoke detector cabinet, and this normally is set to the pipe between the dry cargo space and the smoke detecting cabinet. Okay, so there is a space in which the pipelines are connected and the valve, three-way valves are there. So normally it is in the detecting mode. That means the sample is connected and it is passing through the sampling cabinet. And when you have to discharge, you have to turn it, and the CO2 is manually discharged to that particular cargo hold. So when smoke is detected, valve from the particular space is operated, and thus isolating the smoke detective cabinet. Means smoke is already detected and now you have to charge the CO2. Then in that case you will turn the three-way valve system and opening the pipe to the CO2 cylinder battery, ready for discharge of the gas to the cargo space in fire. Okay, so it is ready to discharge. The system of pipes for the smoke detections are also used for fire extinguishing. Okay, so these are the system of pipes which is there and which is basically connected for this smoke detection and firefighting system part of it. Okay, so you can see that this is basically designed for the cargo space. When we know that the CO2 is basically the CO2 flooding for the engine room part of it, but cargo space also, so both are combined one. Okay, and cylinders are arranged for a gang total discharge of the machinery space, and the separate marking is there for like you have some number of cylinders which is for the cargo space, cargo hold number 1, cargo hold number 2 and cargo hold number 3. The main reason behind the manual discharge or the limited discharge is that the size of the cargo hold. Okay, and usually we are doing the manually release for the individual cargo space. What is the main reason? Depending upon the volume of each space. Means we have the different cargo holds of the different volumetric space, so the number of cylinders will change. So that's why the manual release, gang release is not possible. Instructions will also be posted over there in CO2 room to release the cargo space, CO2, how and what number of cylinders. Okay, so that is also one of the vital point in this system. Okay, here you can see this is the, you can see here these are the redundancy given. So these are the two things you can have that, and continuously the fans are running and the samples are being taken and exhaust. Okay, so one pipe is for suction and then other is for discharge of it. Okay, next you can see here this is the actual sampling connection installed on board ship, and this diagram you can see that the same fan unit, you can see the fan unit over here. These are the PVC pipes which is arrow, you can see the arrow, this is taking the suction, and here you have the all three-way valve arrangements. Okay, so this connection is from the CO2 bottle and this connection is to cargo hold. Okay, so these are the two connections, and one connection, the small pipes are passing through this control unit, and the indication of this HMI panel will tell you the complete information regarding which cargo hold is at fire or what. Okay, and you have the this connectors, and you have the other cargo holds or the spaces, so you can have this sampling arrangements also over here. Okay, and this continuous sampling is done by, so this is the actual part of it, and you have one repeater panel also which is there, and the main panel is in the bridge house. Okay, so you can see this thing, and these are accumulators. So these smoke accumulators basically connected to the end of the sampling pipes in each cargo hold, and that perform the physical function of collecting your samples, and it is basically transmitting it to the control panel through the sampling pipes, and it will act as a discharge nozzle, sorry, for the fixed gas firefighting extinguishing system. Okay, so that is also the part of it. We are going to discuss about the sampling pipes. As we have seen in the earlier diagram, the sampling pipes, they are in the form of network, and it connects the smoke accumulator to the control panel, and it is arranged in the various sections, so it is easy to identify the location of fire, and then the corrective action, that is your the CO2 extinguishing, is also being done or possibly being done. Okay, the next component in this line you have seen already, and this is interconnected to a fixed firefighting system. That means if it is in one position, it is taking the sample, and in another position it is going to basically allow the CO2 to discharge into the cargo hold and extinguish the fire. If the fire is detected, these are realigned, these sampling pipes to the fire extinguishing system, and this is going to discharge the CO2. Okay, and as earlier we have already the detection is done in which cargo hold fire is there, and accordingly the fire is extinguished as required. Okay, so now we are talking about the main thing where you can see and which hold is on fire and what all things are there operating, of scanning, all these things you can do. So the main element of the system that provides the continuous monitoring for the protection of a space or indication of the smoke in which hold the smoke has occurred or the fire has occurred, that is also given on this. Okay, it is basically the viewing chamber or smoke sensing units also attached to this. Okay, extracted air which is from the protected space, or you can say the cargo hold, through the smoke accumulators and the sampling pipe is going to the sensing chamber, and the connection is there between the control panel and that. Okay, and air stream is monitored by the electrical smoke detectors. So the whatever the smoke which is passing through, if at all, from any of the cargo hold, it is being detected by the electrical smoke detectors, and the indication will be given in the bridge. Okay, and crew can determine the smoke sensing unit which cargo hold is on fire, because it control panel the hold number is also being shown over there. This is the electronic arrangement, and then as required we can open the or operate the three-way valve and extinguish the fire. Okay, so now we are going to CO2 cargo space system, the smoke detector system, whatever the operational some requirements. Okay, so this cylinder, whatever the CO2 which is there, this has to be stored vertically, and the discharge valve must be installed on the top, and it is fitted with the internal siphon tube. As we earlier know also that if the siphon tube is not there, then the discharge of CO2 will be done in the gaseous form from the top, and then this is going to slow down the rate, and after some time the latent heat which is taken by the CO2, this is going to for change of state, it is going to freeze also the remaining of the CO2 part. So that's why the internal siphon tubes are being given, and this allows the discharge of the CO2 liquid from the bottom part of it, and liquid is being discharged. As soon as the liquid leaps out from the nozzle, it becomes the gas. Okay, so without the siphon tube, CO2 would evaporate from the liquid surface and pass through the pipe system as a gas, and it gives you a very slow discharge rate. So that we have already discussed. Okay, now in this slide we are going to discuss cargo hold CO2 system. Okay, so this system shall be the system shall be a type that can be tested for the corrected operation and restored to the normal surveillance without renewal of any component. Okay, so that means the regular testing and regular surveillance is being required. An alternative power supply for the electrical equipment used in the operation of system shall be provided. That means the main switchboard connection must be there, and as well as you must have the emergency switchboard power connection also. So both the power supply must be available. So in case of emergency, suppose the main power supply is not there, so you can have the alternate source of power supply available. The sensing unit should be certified to operate before the smoke density, and the sensing chamber exceeds 6.65 obscuration per meter. Okay, so this is something which is the requirement which tells about the obscuration percentage, that is your 6.65. Okay, next SOLAS requirement such a way designed or constructed and installed that they will prevent the leakage of any toxic or flammable gases or the fire extinguishing medium into the accommodation space, service space, or control station or machinery space. So as we have seen earlier in the earlier my video regarding the fixed CO2 installation, the pipelines should not go through the accommodation and all, but in this case the pipelines are going through the accommodation space also, or the engine room part may be also. Okay, so in that case they must be designed in such a manner that there should not be any leakages. As the sampling is also being done So at that time also there should not be any leakage, and when we are discharging the CO2, at that time also there should not be any leakage. So the main fundamental motto is that the leakages should be avoided. The system and equipment shall be suitably designed to withstand the supply voltage variations and any transient or ambient temperature changes, vibration changes, humidity, shock, impact, and corrosion also. Okay, so what happened? We have to make it all proof, so that because this is something which is going to be utilized in case of the emergency, so it should have the you can have the voltage variations, temperature variations, vibrations, humidity, and shock, impact, and corrosion proof type, or you can have the avoidance also, or any possibility of ignition of the flammable gas air mixture, that also to be avoided in this case. Okay, so system should be designed in that manner. Now you can see requirement of the cargo hold CO2 system. That's why earlier previous slides I have described the various components. Okay, so duplicate sample extraction fan should be provided. As we have seen, the two fans are there. The fan shall be sufficient capacity to operate with a normal condition of ventilation in the protected area, and the connected pipe size should determine with the consideration of the fan suction capacity and piping arrangement. That means to say that if the pipe size, the pump size, or the fan size should be in such a manner that it should match with the capability. Then sampling pipe should be minimum of 12 mm the internal diameter. So they are saying that the sampling pipe minimum internal diameter should be at least 12 mm, not less than that. It can be above, it can be more than 12. Okay, the fan suction capacity should be adequate to ensure the response of the most remote area with the required time criteria. So meaning to say that means the from farthermost cargo hold. Okay, let's say about you can say the number one cargo hold. So from there also the fan capability is such a manner that to take the sample, or take the sample of the cargo hold with the sufficient rate. Okay, so this requirement must be fulfilled. Means to monitor airflow shall be provided with each sampling line. Okay, so you can have the monitoring part of it, monitor airflow, and that provide in each sampling line, so it is easy to identify the part of it. Okay, next you can see the another component, control panel shall permit observation of smoke in the individual sampling pipe, so that we can individually see the observation of the pipe. Okay, and we can find out that which cargo hold is having fire. Okay, the sampling pipes should be so designed to ensure that as far as practicable, equal quantities of airflow are extracted from each interconnected accumulator. That means, so the extraction which is done from the number one cargo hold, number two cargo hold, or the subsequent cargo holds, so all airflow quantities should be equal. Okay, it should not that number one it is taking less as it is farther, and number 7 or number 5, whatever is the at end, it will be more. Okay, so it should not be that all air quantities which is being withdrawn should be, or interconnected accumulator should be same. Okay, next, sampling pipe shall be provided with the arrangement for periodically purging with the compressed air. Okay, so if required, purging with the compressed air, suppose it is being choked or anything, so the purging is possible, we can purge it out also, so that requirement is also fulfilled. Okay, so now the testing requirement, the system shall be functionally tested using the smoke generating machine or equivalent as the smoke source. Okay, so this is something which is having the functional requirement. You should have the smoke generating machine so that you can test it. And alarm shall be received. So we can have the alarm system also shall be received at the control unit in not more than 180 seconds for the vehicle deck. So if it is a ro-ro type of the vessel, you have the vehicle deck, and not more than 300 seconds for the container and the general cargo holds. So in that case, these time limitations are given and the testing is done as required. Okay, so I hope you have complete description of the cargo hold fixed CO2 installation, and I have explained in this video the components also, and the SOLAS requirement for this system, and the SOLAS requirement for the components, as well as the testing requirement also. So hoping you that this video gives you the sufficient knowledge and explanation regarding the cargo hold smoke extraction system or the fixed CO2 installation. Thank you again.